Hello students! So this video here is, or this lesson is about solving linear and non-linear systems algebraically. And so again guys, some of you probably remember talking about systems of equations in one of your previous math courses, and then some of you may not remember talking about systems of equations in one of your previous math courses. But again, that's what we'll be talking about in this video: solving linear and non-linear systems of equations algebraically. Guys, when we say algebraically, we mean where you are actually using algebra to solve these equations. And literally you are writing out and showing your work on paper using algebra to solve these equations. Okay? And these ain't the types of equations that you can just do in your head. Okay? So where you actually need to write it down, show it on the paper using algebra. Alright, let's go ahead on and get started. Alright, so guys, we're going to start by discussing the linear equations, or the systems of linear equations. So first off, guys, you should recognize the word linear. Again, it sounds like line, right? And we've talked about linear equations and linear functions. But again, so when we're talking about linear systems of linear equations, we're talking about where you've got a straight line, or linear equation forms a straight line on your coordinate plane. But again, guys, there are two different ways that you will see linear equations written when we're dealing with these systems of linear equations. And so that's what we're going to start off by talking about: the different ways that linear equations can be written, and the different ways you'll see them written. Alright, so guys, a linear equation has a graph that forms a straight line on a coordinate plane, and again folks, any linear equation can be written in two forms. And so guys, for this particular lesson, for the part that we're talking about with linear systems of equations, you'll see those equations, those linear equations written in these two forms: slope-intercept form and the standard form for a line. So guys, you should remember, if nothing else, you should remember the slope-intercept form. The slope-intercept form of a line is the form y equals mx plus b, where all the variables represent real numbers. And guys, again, I'm sure that you've talked about it in a previous course, but again, depending on what's going on, you may or may not remember, or may not have had a chance to cover it. COVID-19. Anyway, alright. So guys, for the slope-intercept form of a line, and again, that's that form y equals mx plus b. The m represents the slope of a line, and the b represents the y-intercept of the line. Again, folks, we don't really have enough time to go into all of that detail about slope-intercept form, graphing it, and all that stuff. But again, you'll see some of these linear equations in this form: y equals mx plus b, and again, you'll have m, where m is going to be some number and b is going to be some number. And again, guys, x and y just represent any paired set of input and output values on the line. But again, guys, when you see the equation, x and y are still going to be written as x and y. But again, you'll have a number in the place of m, and you'll have a number in the place of b. Anyway, the standard form of a line is that form ax plus by equals c. And again, in that form, like that, all of the variables represent real numbers. But again, guys, and again, for this particular form, the x and the y will still be written as variables, But guys, the A, B, and C are usually written as integers, and I say usually. It doesn't have to always be, but usually the A, B, and C are written as integers. You should remember what integers are. Integers are positive or negative, and again they include both positive and negative whole numbers. And the set of integers also includes 0. So we're talking about negative whole numbers, positive whole numbers, and 0 when we say integers. All right. So again, you'll see these linear equations in the system written in these two forms. So for those of you who are wondering, okay, Mr. Starkey, you're saying that we'll see the linear equations written in these two forms, the slope-intercept form and the standard form. Okay, but what is a system, Mr. Starkey? I'm so glad you guys asked. A system is a set of two or more equations. If you did not know that already, a system of equations is a set of two or more equations. So again, guys, a system is a set of two or more equations. And folks, since we are talking about solving linear and nonlinear systems, guys, solutions for a system are going to be any ordered pair in the form of x, y. So a solution is going to be any ordered pair in the form of x, y that satisfies all of the solutions in that system. So again, folks, a system of equations is a set of two or more equations. Solutions of a system. Ooh, why didn't y'all tell me I spelled that wrong? Give me a second. That doth look better. All right. So again, guys, the solutions of a system of equations are any ordered pair or any ordered pairs in the form x, y that satisfy all the equations in that system. And so, guys, as an example, the ordered pair 2, 7 is a solution of the following system. And so I'm not going to read out what that says, but again, y'all can read that. Yeah. Of that system right there. And you can see this system has two equations in it. All right, so guys, and again, that ordered pair 2, -7 is a solution of this system because when we plug in 2 for the x value and also, of course, plugging in -7 for the y value, both equations are true. Both of the equations are true when we do that. And so, again, guys, you can see here that what we've done is, just give me a second, yeah? Oh, nope, not like that. That'll work for now. Don't have to. All right. So you can see what we've done here is again we've plugged in the x value for x in both equations, and we've plugged in the y value for y in both equations. And guys, if you ever want to check to see if an ordered pair is a solution for a system of equations, then you can do that. Okay. So again, for that first equation, -3x minus y equals 1. We plugged in 2 for the x value and -7 for the y value. And again, when we plug that in, we do end up getting that both sides of the equation is true. So again, that's true. When we do -3 times 2, that gives us -6. And then when we subtract a -7 minus -7, that's almost like adding 7. So this first equation, that top equation, after we plug that in, is like having -6 plus 7, and that is equal to 1. All right, and the same thing is true for the second equation, pretty much. that the left side of that equation is equal to the right side when we plug in that. So again, guys, a system is a set of two or more equations. The solutions for any system of equations is an ordered pair that satisfies all of the systems in that that satisfies all of the equations in that system. Guys, since this is since this lesson here is about solving these types of systems of equations, is about solving these systems of equations algebraically, we need to discuss two particular methods that we'll be using in today's lesson, and that you'll need to show and use for your practice problems. Because of course, guys, I'm requiring that you submit a picture, and this is for my students who are enrolled in my class at our school. I'm requiring that you submit a picture of your work, showing your work written out algebraically, where you've written it out by hand on paper, and you take a picture of your work. Don't show me a picture of a screenshot that you completed Delta Math. I don't need a screenshot of that because I can see that on deltamath.com. What I need a picture of is of your work, handwritten, showing that you have worked these problems out by hand algebraically as I've asked you to do, and as I'm about to show you how to do in this video right here. All right, so we're going to show you how to do that algebraically, and there's two methods that we're going to discuss here. The first method that we're discussing here is the substitution method. Okay, and so we're going to talk about the substitution method for solving systems of equations. And right now, since we're focused on linear equations, systems of linear equations, we're going to talk about how to solve systems of linear equations using the substitution method. Substitution method coming right up. Okay, so guys, this substitution method is a method that involves substituting or replacing an equivalent expression for a solved variable of one equation into the other equation. Now, I know that's a mouthful, and it sounds like it probably sounds like I'm speaking Greek when I said that this method involves substituting or replacing an equivalent expression. So it involves substituting or replacing an equivalent expression. Okay. In other words, you're replacing some type of equivalent expression when you have a solved variable. In other words, when you have an equation where you have solved for that variable. So you're going to replace. Anyway, I'm about to show you exactly how to do it. So if these words here ain't doing it for you, that's fine. You'll see what we mean when we say that it involves substituting or replacing an equivalent expression for a solved variable of one equation into the other equation. You'll see exactly what we mean by that in just a sec. Okay, we're about to show you a few examples of how to use the substitution method, and then you will see exactly what we mean by that. Okay, all right. All right, so again, guys, we're going to look at maybe 2 or 3 examples with solving systems of equations using the substitution method. And so let's go ahead on and start here with this first one. Yeah, example 1. All right, so let's say that we got here in this example these two equations as our system. 3x plus 5y equals -2. And for the other equation, let's say we got 6x plus 7 equals x. Oops, my bad. That's 6y plus 7 equals x. Aha. Here we go. Yeah. All right, so let's say we had those two equations there as our system, and we wanted to solve it by substituting. So, guys, and again, some of your Delta Math problems that you're assigned for today's lesson, now I'm talking to my students who are enrolled in my class at our school. Some of your Delta Math problems that you're assigned to do for today's lesson specifically state to use the substitution method. Now, guys, if you're going to be showing your work and it specifically says use the substitution method, guys, if you use the other method when it says use the substitution method, that means you didn't follow instructions. That means you're definitely not trying to get all of your points for that part of the assignment of showing your work. So, okay, anyway, so guys, if you are asked to solve using the substitution method and you see that one of the equations is already solved, you see that one equation has already been solved for a variable, okay. So in this case here, for this example, please notice that one of the equations has already been solved for a variable. Y'all don't really need to see me writing this, but it's okay. I'll pause it the next time I write so it doesn't take up precious video time. Okay. Notice that again, guys, this equation has already been solved for a variable. And so, guys, since that is the case, and we've got an equation that has already been solved for a variable, then, guys, we need to, okay, let's try that again. We need to, better, a little bit, not really. Ugly arrows, there we go. That's a good looking arrow. All right, what we need to do is we need to, so I notice how I said, guys, that we need to substitute the equivalent expression. So if you got an equation that's already been set equal to one of the variables, guys, how this says x equals or something equals x, right? In this particular system. So, guys, this right here is that equivalent expression that I'm talking about. This right here is this equivalent expression. Okay. Oops, that ain't how you spell equivalent. Let's try that again. Okay, so again, so when we're talking about substituting that equivalent expression into the other equation, all right, so guys, the other equation, so we're talking about substituting that equivalent expression. Yeah, you see it? I got it boxed in, that equivalent expression, and we're talking about substituting it into the other equation. Guys, the other equation is 3x plus 5y equals -2, right? Give me a sec. Yeah. Go back. There we go. That other equation is 3x plus 5y equals -2. So we're talking about substituting this equivalent expression into this other equation. In other words, into the equation that hasn't been solved for a variable, right? The other equation that hasn't been solved for a variable. All right, and the place where we're going to substitute that equivalent expression is simple. Okay? So when we say that this is an equivalent expression, what is this an equivalent expression for? This 6y plus 7 is equivalent to what? It's an expression that's equivalent to x, right? Because we know that an equation sets two equivalent expressions equal to each other. So this expression 6y plus 7 is equivalent to none other than x, guys. So what we need to substitute in this other equation is x. Yeah, I didn't want that to be a parallelogram, but that's okay. We'll see if we can get it to be a rectangle. There we go. That's a little bit better. So again, what we need to substitute in this other equation, we need to substitute it for x, because that's what that expression is equivalent to. Okay? So in this equation, in this other equation, we're going to replace x with that equivalent expression. Alright, so again, we're going to replace x with that equivalent expression. Okay, so again, guys, we're going to substitute that equivalent expression for x, which is that 6y plus 7, and we're going to substitute it from that solved equation into the other equation. And guys, we're going to replace x. Okay, so let's do that now, and let's write out that. So when we replace that, this is how it's going to look. Okay, if I can write that straight. Only if. Alright, so let's see here. If we replace that, now that's going to be, okay, so we already had the 3, but we're replacing x with this equivalent expression. So we're replacing this x with the 6y plus 7, and we're substituting x for this equivalent expression here. So we've now replaced the x. So instead of us having x written here beside the 3 or multiplied times the 3, now we've got 6y plus 7, that equivalent expression. All right, and we're just going to bring down the rest of this. Still got the plus 5y, still got the equals -2. All right, so from here, guys, what we would need to do is solve the equation for really the only variable now that we have. So, guys, after we replace, or after we substituted that x with the equivalent expression, now this equation that you see, now the equation only has one variable in it. You guys notice that, right? So now that the equation only has one variable in it, now we need to solve for that variable. Solve the equation. Okay, so again, folks, we noticed that after we substitute, this new equation only has one variable, and we need to solve for that variable. For this particular equation, we're going to distribute the 3 that's on the outside of this parentheses, and then we're going to combine like terms, and then we're going to go ahead on and finish solving. When we distribute this 3 inside of here, that gives us 18y plus 21, and this is still plus 5y and equals -2. When we combine the like terms on the left side of the equation, that's 18y plus 5y, which is 23y plus 21 equals -2. And of course, we need to subtract 21 from both sides of the equation. That's going to give us -23 on the right side of the equation now. So we've got 23y equals -23. And then, of course, guys, the last step, of course, is to divide by 23 on both sides of the equation. Oopsie. Alright, so here y equals -1. So, guys, we are not done. we only have the value for one of these variables. Remember, guys, that I told you that a solution for a system is an ordered pair in the form of x, y that satisfies all the equations. So again, guys, right now all we have is a y value. We need an entire ordered pair, and we need to write the solution as an ordered pair in the form of x, y. And again, guys, that means that we need to not only have a y value like what we have here, but we need to know what the x value is as well. So guys, after you have found one of those particular variable or values for one of the variables, then what you need to do is you need to substitute that value that we've just found back into one of the equations to solve for the other equation. So again, we know now we know that y equals -1, so we can choose either one of these two equations, and we need to plug in the value of -1 for y, and then we need to solve for x, solve for the other variable. So plug in the value that we just found and solve for the other variable. So in other words, we substitute again. Substitute the -1 in the place of y, and then solve for x. So again, folks, after we found that value for one of the variables, we substitute that value into the other equation, into either equation, and we'll solve for the other variable. Alrighty. So again, guys, it doesn't matter which equation you choose to plug that into. Since we already have one equation that's already set equal to x, and that's the other variable that we need to find, I'm just going to use that equation that's already set equal to x. Okay. Alright, so let's plug that in. Let's use so again, that equation is, wow, really, that equation is 6y plus 7 equals x, and again we're going to go ahead on and replace that with the value that we just got here. So we're going to go ahead on and plug that in. Oh, that is sloppy, but you know what? It gonna have to do. Yeah, it gonna have to do for right now. Sloppy and all. Alright, we're gonna plug that in. So instead of writing y, we're gonna write -1 in its place. We're gonna substitute that. So that's 6 times -1 plus 7 equals x. 6 times -1 is -6, and when we add 7 to that, -6 plus 7, we get 1, positive 1. So x equals positive 1. So are we done? Not really. Why we're not done? Well, Mr. Starkey, you said that a solution is an ordered pair where it's in the form of x, y. So why are we not done? We got the x value, we got the y value. Okay, so we have an x value and we got a y value. But what else did I say? I said that it's in the form of an ordered pair, in the form x, y, with the parentheses, an ordered pair. You got to write the answer, the solution, as an ordered pair. If it's not written as an ordered pair, I don't know what you're giving me. I don't know that that's a solution. I don't know. I don't know if you don't write it as an ordered pair. I'm just going to go ahead on and tell you. Alright, so again, the solution here, your for real solution. Now that we have found an x value and the y value, our solution is the ordered pair of 1, -1. The x and the y value put together in the form of an ordered pair in that form of x, y. And guys, that's that first example right there. where we have solved this system of equations. Alright, we're going to look at a few more examples. Yeesh, okay, that's about as sloppy as it's going to get. We're going to look at a few more examples with the substitution method, and then we're going to talk about the other method. And we'll get there in just a moment. That looks better. All right, so that's the first example where we solved this system of linear equations using the substitution method. And guys, this first example was one where it already had one of the equations solved for a variable. So again, in this first example, we started off having it where one of the equations was already solved for a variable. Alright, so let's look at example 2 here. Example 2, let's say we're asked to solve this system of equations. 2x minus 3y equals -6. And the other equation, 2x plus 4y equals 22. Alright. So with this one, it's not quite like the first one, right? Because the first example, in that first example, we already had one of the equations that was set equal to a variable, but in this one we don't have that. So for this one, the first thing that we're going to need to do if we want to substitute is we need to solve one of these equations for a variable. And so guys, you're going to need to sort of, well, not need to, but I will say this, guys, if you don't like working with fractions, you may want to kind of think a little bit ahead and think about which one of these equations it would possibly be easier to solve one of the variables for, where it would not leave you with a fraction. So it would be easier to solve the second equation here, and it would be easier to solve that second equation for x, where it would not leave you with a fraction. So that second equation, 2x plus 4y equals 22. We're going to solve that one for x. But again, the first step is to solve one of the equations for a variable. Doesn't really matter which one, but to make it easier on yourself, I suggest doing it if you recognize doing it with the one that's going to not result in you having a fraction. Again, folks, as we said, we're going to go ahead on and solve one of the equations for a variable, since neither equation is written as being solved for a variable yet. So again, we're going to take this second equation here and solve it for x. So if we subtract 4y from both sides, minus 4y, that's 2x equals -4y plus 22. And we still divide by 2. Guys, when you divide by 2, make sure that you divide every single part by 2. Every single term, every term divided by that number. Okay? If you don't, you'll be doing it wrong. Divide every term by that number. Alright, that's going to leave us with x equals, and this is -4 divided by 2, which is -2y, and then 22 divided by 2 is 11. Alright, so we have solved one of the equations for for x. And now, guys, we're in the same predicament as we were with the first example, where now that one of the equations has been solved for x, now we need to go ahead on and take that equivalent expression and we need to substitute it. Yeah, I thought that was going to form a little box like that right there. All right, so we need to take this equivalent expression and we need to plug it into our other equation, right? So this equivalent expression, we need to go ahead on and plug it into the other equation. All right, and let's plug it into the other equation. All right, and we know that the other equation is what was that? 2x hold on. Let's try that again. It's 2x minus 3y equals -6, and we know that that's our other equation. So we need to plug in this equivalent expression into this equation for that variable. Alright, so we need to do that, and we need to plug that in there. Okay, so again, guys, when we substitute that, we've got the 2 there, and it's being multiplied by x, but again, we're replacing the x with this equivalent expression, and instead of x, we're going to write -2y plus 11, and this is where we at? Yeah. So now we have replaced x with that equivalent expression, and guys, we still need to write the rest of this equation, the rest of this other equation here. Other equation. Okay, and we still need to write the rest of this other equation, which is -3y equals -6. Right. All right, and so we're going to distribute that 2 inside the parentheses, and then we're going to combine our like terms and finish solving. All right, so when we distribute the 2, we got here -4. I said -4, but I wrote the wrong thing. We got -4y plus 22. We're going to bring down this, still -3y equals -6. We're going to combine our like terms, -4y and -3y. That gives us -7y, and we're going to bring down plus 22, and the equals -6. We subtract 22 on both sides of the equation. We'll wind up having -7y equals -28. Then our last step here, when we divide by -7, we end up getting, that y equals +4. Okay, are we done, folks? Yeah, y'all got it. You know that we not done, right? Because we definitely got to write our answer as an ordered pair. You know that already. If you don't, that's what we're talking about right now, so you can learn it. Alright, so we only have one component of that ordered pair. We only have the y value. And again, guys, we need to go ahead on and substitute that into either of the equations and then solve for our other variable. Alright, so again, guys, we need to take this value of y and we need to substitute that into either of the equations that we already had before here. And I'm just going to choose this this equation that we had solved for x, because that's going to be the easiest thing to plug this y value into. And so I'm going to choose that one where we got x equals -2y plus 11, and we're going to plug in and substitute that y value of 4, and we're going to replace and plug it into this equation where we see y. Okay. That's not the neatest of arrows, but it had to work for now. Alright, we're going to plug that in right there. Okay, so if we plug in this y value of 4, that's going to be x equals, excuse me, it's going to be x equals -2, and instead of y we're going to write 4, right, plus 11, and when we solve, or when we simplify that, we've got -2 times 4, which is -8, and -8 plus 11, which winds up being +3. So that is the x value. The x value is +3, the y value is 4, which means that this solution, the solution here is the ordered pair of 3, 4. Alrighty, so there we go. Alright, so that was this problem here. And again, guys, for this example, it started off where neither of the equations have been solved for a variable. But again, what we had to do to start it off was we had to solve one of those equations for a variable. Alright. Alright, we're going to look at one more example like this. It's slightly different, but with using substitution, and then we'll move on to the other type, to the other method of solving linear systems algebraically. Alright, next example coming right up. Okay, so example 3, solving it using the substitution method. For this one, guys, notice how both of the equations here have already been solved for the same variable. So again, in this example, if you'll notice how that both of the equations have already been solved for the same variable. When that happens, guys, and you and both of the equations are solved for the same variable, then what you need to do is really the same thing that we've been doing, but again, it may not seem like the same thing, but really the same thing. So when both equations are solved for the same variable, guys, first let me just kind of write it out like this, right? Real quick, guys. So first off, everybody realizes that y equals y, correct? I hope so. I really hope so. I really do. I really do hope so. So, guys, here we have two equivalent equations, or sorry, two equivalent expressions. This part, the 5 minus 3x, and this part here, the 5x minus 11. Yeah, okay. I thought it was going to do my little thingy where it turns into a rectangle. There we go. All right, so we got two equivalent expressions, right? And both of them are equal to y. Both of them are equal to y. So guess what? Guess what we're going to do? We're going to substitute. We're going to substitute. In other words, guys, since both of these are equal to y, and technically since y is equal to y, right? Y is equal to itself, and both of these are equal to y, that means that both of these are technically equal to each other. Both of those equivalent expressions are equal to each other. And so that's what we're going to do. We're going to substitute, and we're going to set those two equivalent expressions equal to each other. Okay, so guys, when we get ready to substitute those two equivalent expressions, we're going to set them equal to each other. All right, and so again, since y is equal to y, that means that 5 minus 3x is equal to 5x minus 11. And so here, again, folks, we're going to solve. So we're going to solve for the x. Let's see here. If we add 3x to both sides, that gives us 8x. Still got the minus 11 on the right side. Still got the 5 on the left side. If we add 11 to both sides, that gives us 16 on the left side. 16 is equal to 8x. And then if we divide by 8 as our last step, 16 divided by 8 gives us 2 for the value of x. Alright, so x equals 2. Alright, and so guys, since we've got that value for x, again folks, now we're going to need to go ahead on and solve. Yeah, we're going to go ahead on and need to solve for our other variable. Alright, so let's go ahead on and substitute this value here, the value for x, and let's substitute that into this other equation, either of the other equations. And we already had both of those original equations set equal to y, so I will just use one of those, either one. 5 minus 3x, y equals 5 minus 3x, okay? And we'll substitute that x value here into this equation. Okay, alright, and so we still got the 5 minus 3, and instead of writing x, we're going to replace it, substitute it with the value that we just found of x equals 2. And so from here, negative 3 times 2 gives us negative 6, and then when you do 5 minus 6, that winds up being negative 1. Alright, so y equals negative 1. Now we've got both the x value and y value, but again, our solution for a system needs to be written as an ordered pair. And that ordered pair here is 2, negative 1. Alright, so next, guys, we're going to look at our other method of solving systems. Okay, so again, guys, we are going to take a look at the other method for solving linear systems of equations. But guys, we're going to have to do that in part 2 in the video. In the part 2 video, so stick around for more in part 2 video. Yeah, because it's late, I gotta go, but anyway, stick around for part 2, the video there for today's lesson, and we'll show you, and we'll kind of pick up where we left off. Alright, so and again, just to give you a little peep view, the name of that second method for solving systems of linear equations, that second method is called the elimination method. And actually sometimes it may be called, or depending on where you're looking or what book you're looking in, it may be called the addition method. So again, that second method is called the elimination method or the addition method. Please stick around for part 2 of this video, solving linear and non-linear systems of equations. Alright folks, I hope that this video has been helpful. We're not done yet, because again, there's a part 2 to this, so stick around for the next part.